Okay, so in this lesson, we're going to be going through exercise 5C, which is all about adding and subtracting terms. What are our learning intentions? To understand that like terms contain exactly the same pronumerals, possibly in a different order. To be able to decide if two terms are like terms. To be able to combine like terms to simplify expressions. Okay, what's our starting activity? Our starting activity is to simplify an expression by combining like terms. So here we have an example, and instead of pronumerals, I've actually used just fruit here. Now, if I said I have 2 apples, 3 bananas, 3 apples, and 5 bananas, what is a better way of saying this? What is a simpler way of saying this? Because it's asking us to simplify it. So what's a simpler way of saying this? Well, instead of saying I have 2 apples plus 3 apples, why don't I just say I have 5 apples? I will combine those two things together. So too, instead of saying I have 3 bananas plus 5 bananas, why not just say I have 8 bananas? So again, I'm combining the like terms. And we're going to be learning about what this word like term means very soon. But just to get like an instinctual understanding of it, what we're doing is we're bringing together those things that are the same. So now if we come over to the same question, but now use pronumerals, if I had 2x plus 3y plus 3x plus 5y, instead of saying 2x plus 3x, why not just say 5x? So too, instead of saying 3y plus 5y, why not just say 8y? And we are here combining like terms to simplify an expression. So let's now figure out what like terms strictly mean. So example 1, identifying like terms. Like terms are terms containing exactly the same pronumerals, although not necessarily in the same order. So 5ab and 3ab are like terms because they both contain AB. 5a and 7b are not like terms because a and b are not the same. 2acb and 4bac are like terms because they contain exactly the same pronumerals a, b, and c. A, b, and c. The only difference here is that they are not in the same order, and that's what our definition says here. So let's reread our definition. Like terms are terms containing exactly the same pronumerals, although not necessarily in the same order. So even if they're not in the same order, it doesn't matter. They just have to have the same bunch of pronumerals. Okay, so let's now see if we can classify the following pairs as like terms or not like terms. Okay, 3x and 2x. Well, they contain the same pronumeral, x, so they are like terms. What about 3a and 3b? Well, this term has a as a pronumeral, and this term has b as a pronumeral, so they are not like terms. What about this one, 2ab and 5ba? Well, as you can see here, they both have AB. Even though they're not in the same order, they both contain the same pronumerals, so they are like terms. Over here, we have negative 4k and k. Well, they both contain k, so that means they are like terms. Let's come over here. What about 2a and 4ab? Well, this one has a and this one has ab, so they don't contain exactly the same pronumerals, so they are not like. Let's move on to the next one. Here we have 7ab, and over here we have negative 9aba. Well, they don't have exactly the same pronumerals. This has ab, and this has aba. They're not the same pronumerals, so these are not like. Let's now move on to terms that have powers. So here we have 4x squared y, and over here we have 2x squared y. Well, they both contain x squared y. X squared y. So that means they are like terms. And if we were to write this out a different way, so let me just write down their like terms. What this means is that I have 4xxy, because I have 2 x's, and over here I have negative 2xxy. So as you can see, I have 2 x's and 1 y, 2 x's and 1 y. So they have exactly the same pronumerals. Let's now answer this one. This is 2ab squared and 4ba squared. If I was to write these out in full, this is 2abb, because b is squared, and over here this would be 4baa, because a is squared. So as you can see, here I have 2 a's, here I have 1a, here I have 2 b's, here I have 1b. So they do not contain exactly the same terms, So these are not like terms. They don't contain exactly the same pronumerals, rather. They don't contain exactly the same pronumerals. Okay, let's now move on to our next example, which is collecting like terms. Like terms can be combined within an expression to create a simpler expression, that is equivalent. For example, 4ab and 3ab can be simplified into 8ab. If two terms are not like terms, they can still be added to get an expression like 4x plus 5y, but this expression cannot be further simplified. And lastly, the sign in front of the term stays with the term even when it is moved. Okay, so we're going to be seeing how all this theory is going to be enacted as we go through these examples here. So the first thing we have to do is simplify the following by collecting like terms. So we have to collect like terms. So let's start with our first example here. What I want you to do, just to start off, is I want you to highlight the like terms, where here I have 7b, and over here I have plus 3b. And as you can see, I've highlighted the plus in front of 3b, because this sentence right here says, the sign in front of the term stays with the term even when it's moved. So the sign in front of the term stays with the term even when it is moved. So make sure you're always highlighting the sign in front of the term. Now, plus 2b is not a like term because it doesn't contain that pronumeral b. Now what I'm going to do is I'm actually going to move my two like terms next to each other. So 7b plus 3b, and then I have this plus 2 here. So what I've done now is I've moved my two like terms next to each other, and then the term that is not like I've put by itself. Now I can collect these like terms. So what is 7b plus 3b? Well, that's going to be 10b, and then I just have to plus this 2 on the end. That is going to be my answer. So I have simplified the following by collecting like terms. Let's now move on to our next example, and we're going to use the same methodology here. We're first going to highlight our like terms. So here we have 8a, and here we have plus a, and now we also have plus 2b plus 3b. I'm now going to rearrange them so that all my like terms are next to each other. So I have 8a, and I have plus a, I have plus 2b, and I have plus 3b. So what I've done here is I've simply put my like terms next to each other. All my a are next to each other, and all my b's are next to each other. Now I'm going to join them together. So 8a plus a is 9a, and 2b plus 3b is 5b. The way that I'm doing this is I'm just adding together the coefficients in front of them. So that is my answer there. Let's now move on to our next example. Again, we're going to highlight our like terms. So here I have 9, and here I have 3. And as you can see, I'm calling them like terms because these ones don't have any pronumerals at all. They're just constants, and I join those together. I also have plus 2a, and I also have plus 2b, which aren't like terms. So as you can see, I have 3 things going on here. I now am going to join these together. So I have 9 plus 3 plus 2a plus 2b. So what I've done is I've moved my two constants next to each other, and then I have my a here, and then finally at the very end there, you can see I have my b term. Now I'm simply going to add them together. So the only thing I can add together here is this 9 and 3, which will make it 12. This will be 2a, and this will be 2b. As you can see, the 2a and the 2b stay separate. I can't add them together because they're not like terms. Okay, let's now move on to this one right here. So it looks like we've got a lot going on here. So let's begin. So I've got 12ax, I have plus ax, and I have plus 9ax. So all of those have like terms. I also have plus 2a, and I have plus a on the end here. And then finally, I have plus 7b. Now, let's bring all these together. So I have 12ax, I have plus 8x, ax, I have plus 9ax, I have plus 2a, I have plus a, and I have plus 7b. So I've just moved all the like terms next to each other. So I have all my ax terms next to each other. I also have all my a terms next to each other. And finally, I have that b term at the end by itself. That can't be joined with anything. So that now means I can go 12ax plus ax plus 9ax. Well, ax plus 9ax will be 10ax, plus 12ax will be 22ax, and then I'll have plus 3a here, and I'll have plus 7b on the end, which can't be joined with anything. So that is going to be my simplified expression. Perfect. Hopefully all of that makes sense, and I've really kind of held your hand through those examples. We're now going to see other examples as we go. So let's just go through some more examples here of collecting like terms. So again, I've repeated this very important sentence that says the sign in front of the term stays with the term even when it is moved. Now, the reason why I've put that sentence in again is because that's very important now that we have negatives in here. So again, our first move is always going to be highlighting our like terms. So 5 and plus 12, and then I'm going to have plus 4b. Oh, I've forgotten one. You've also got that minus 2 there as a constant. And then we have minus 3a there. Okay, so that means I'm going to have 5 minus 2 plus 12 plus 4b minus 3a. So here I'm going to have 5 minus 2 plus 12. Well, that's going to end up being 15. And then this plus 4b and this minus 3a, nothing can be done with those. They just stay as they are. So that's going to be my answer there. Let's now move on to our next one. Making sure that you're always highlighting the sign in front of the term. So here I have 10uv. Here I have minus 2vu. So that's still a like term because it contains the same pronumerals. Then I'm going to have plus 3u. I have another u term over there, and then finally I have this plus 2v at the end. So now I'm going to combine these together. So I have 10uv minus 2vu, and I might even write this as uv because it's the same thing. Then I have plus 3u plus 7u, and then I have plus 2v. What's very important is I have this negative sign here, which I took from here. So 10uv minus 2uv will be 8uv. Then I'm going to have plus 10u plus 2v. And that is going to be my answer. Let's now move on to our next one. So as you can see here, I have, and I'm not going to use my highlighter now. I'm going to see if I can move through these a bit quicker. I have minus 8x squared plus 3x squared. So minus 8x squared plus 3x squared. Well, if I was to add those together, I'm going to end up with minus 5x squared because they're like terms. And then I've got this plus 4 on the end. And that's going to be my answer. So again, I identified my like terms and I combined them together, making sure I'm taking note of those signs. Let's come over here now. Here I have 6mn, and that's the only mn term I have. I have 8m squared. I have minus 2m squared. And you know what? This might be easy if I do use my highlighter. Let's use my highlighter. So I have this one, which is the same as that one, making sure you're including that sign in front of it. I have this, and then I have this n squared. So now, if I join those all together, I'm going to get 8m squared minus 2m squared. Then I'm going to have plus 6mn plus 5n squared. Okay, so now what I have to do is I have to combine together all the m squared ones. Then that one is by itself, and that 5n squared is also by itself. So if I have 8m squared minus 2m squared, that's going to be 6m squared plus 6mn plus 5n squared. And that is going to be my answer. Let's come down here. And again, we're going to highlight our like terms. So I have 11k, and I have minus 2k, making sure you're including that sign in front of it. I have minus 3k squared and plus 5k squared. So that means I'm going to have 11k minus 2k minus 3k squared plus 5k squared. So as you can see there, I have these, and then I have these like terms as well. So that means altogether, I'm going to have 11k minus 2k is going to be 9k, and minus 3k squared plus 5k squared is going to be plus 2k squared. And that is going to be my answer. Let's now move on to our very last one, which is this monstrosity. So we have 9x squared y. This is different because this one has y squared, and this one is the same. We've got a different order, but it's y and x squared, making sure you're including that negative in front of it. And then my other two aren't like terms. So that means I'm going to end up with 9x squared minus 20yx squared. That's going to end up being negative 11x squared y plus 3x minus 4y squared x. And that's going to be my final answer. So I skipped a few steps there in answering that. And as the more examples you do, the quicker you'll be able to answer these questions. So just make sure you're being careful to include that sign in front of it. So that is the big mistake that people always make. The big mistake they make is they don't realize they have to include the sign in front of the term. Okay, and the last thing that we're going to do here is just quickly show you that we are finding equivalent expressions here. So here it says collect like terms to determine equivalence. So which of the following expressions is equivalent to this right here? So we're going to figure out that by just combining these terms. So here I have 12x, here I have minus 2x, so that's 10x. Here I have minus 5y, here I have plus 7y, so that's going to be 2y. That is not equivalent to what we have been given up there. So that's not equivalent. Next, we have 12y minus 2y, that's 10y. Then we have plus 3x. Well, is that the same as what I've been given here? 10y plus 3x. No, I have 10x plus 3y, so that's not equivalent. And then lastly, I have 9x plus x, that's 10x, and 5y minus 2y, that's plus 3y. Well, here I have 10x plus 3y. Here I have 10x plus 3y. So that means they're equivalent. So gathering like terms is perhaps the most efficient way of figuring out when terms are equivalent. In our last lesson, we went through a way of figuring out equivalence by using substitution and also by considering some arithmetical laws. But the most efficient way is by collecting like terms. And you've seen that right there. Okay, so with that being said, that is everything we needed to go through. We did lots of examples, so hopefully you feel comfortable with collecting like terms. And with that, I will see you in the next lesson.